Everybody, we have a request to do a problem from a winter 2021 exam in part 4. So we're going to go over there and do that. Winter 21, test 1, part 4. And my picture's in the way here. And we're supposed to draw the 2 chair conformations for the disubstituted cyclohexane below. That just means there's 2 carbon groups on it. And the carbon groups are, well, it's more than disubstituted. It's got bromines on carbon 2. It's got a hexyl on carbon 1 and an isobutyl on carbon 4. And we don't even know if it's cis or trans, but we have to figure that out before we start. So we're going to do like a little pre-question just to figure out which groups are up and which groups are down. And I shouldn't be standing over there when I'm doing a video. So we need to do a pre-question to figure out which groups are up and which groups are down. All right. So this is not worth any points, but if you don't do it, you won't get any points. What? You better do it just to figure out which groups are up and which groups are down. So no points, but necessary. You draw a normal hexagon. Okay, this is not a chair at all. It's a chair question. You're not drawing chairs, you're not getting points. But here we go. Hey, carbon 1, top right. Good convention for us to use. 1, 2, 3, 4. We've got bromines on 2 of them. Please draw them like this. I've seen students draw this many times in the past, and they'll say, okay, dibromo, that just means what? Br2? No, that would mean a bromine attached to another bromine. And that's not what bromine does. Do not do that. Okay, good. Carbon 1 has a hexyl. And notice I'm just doing normal bonds, no wedges or dashes yet. 1, 2, 3, 4, 5, 6. And carbon 4 has an isobutyl. You draw 3 in a row. So you start with a propyl and you put a V on the end. And we just need to figure out, I'm sorry? I put it on 3 because I wasn't paying attention. I'm glad you caught me before I went further. Put on 4 like the question says. 1, 2, 3, 4 with a V on the end. Thanks. Yeah, whoa, that was close. All right. Now, the only 2 stereocenters are which 2 carbons? Please don't tell me carbon 2 is a stereocenter. It's not. Which 2 carbons have stereocenters? 1 and 4. So I need to see all 4 groups on those 2 atoms, those 2 carbons. And now we'll do R and S rules for 1, 2, 3, 4 for the substituents. And I'm just going to assume you've been really studying these things hard. I know it was brand new Monday, but I'm just going to get right to it. A carbon with a bromine is going to beat a carbon that is a CH2 that has no bromine. And the CH2 is going to beat the other CH2. For this reason, CH2 goes to CH2 goes to a C with 2 bonds to C. CH2 goes to a CH2 goes to a CH2 with only 1 bond to C. Or really, I went too far. CH2 goes to a CH2. It goes to a C with only 1 bond to C. I think I said that twice. And then the 4, of course, in this example is the H. And go ahead and connect 1, 2, and 3 and see if it gives you R. There's 2 scenarios. Connect 1, 2, 3. If it gives you R and the question says I want R, put the 4 on a dash. The other scenario is connect 1, 2, and 3. And if it gives you the wrong direction, put the 4 on a wedge. There's the only two scenarios, people. This is a great strategy. If you connect the 1, 2, 3 and you get the correct direction, and in this case clockwise, because it has to be R, then you put the 4 on a dash. I'll do that in pink. And please put the carbon group on a wedge. Okay, we've done the one stereo center. Same deal for the number 4. Number 4, which CH2 has a higher priority? We'll go with numbering in, I don't know, orange. A CH2 that goes to a C that has a BR beats a CH2 that goes to a branched carbon, which beats a CH2 that goes to an unbranched carbon. There's no branch off this, so the branch here beats this. And when you're talking just C's and H's, branched carbons always beat unbranched carbons. And 4 is the H. And I was double lucky. What do I mean by that? Number 4 is also supposed to be R. And it currently is clockwise. So the 4 group is going to go on a dash.
The 3.
Yep.
The wedge.
Don't do the wedges in the ring because we don't have a way to draw that when we go to chairs. Put the wedge outside the ring. Just remember, you got 2 things outside the ring. One's got to be a wedge. The other's got to be a dash. This strategy will help you with this problem every time. And so put the isobutyl on the wedge. If it was a nomenclature question, what this lady said was fine. Just make sure your wedge and dash are adjacent to each other. Okay. I want to make this very clear. When you draw your chairs, I don't want any wedges or dashes. The purpose of learning chairs is so we can get rid of wedges and dashes and replace them with an equivalent. Okay? So all I need from the wedges and dashes are these 2 facts. Wedge equals up. Dash equals down. That's all. So when you draw your chair, make sure this group is up, it's on a wedge, and this group is down. That's what dash means. All right, so now finally we get to our 2 chairs. And unlike in our lecture, I'm just going to go monochromatic because I assume everybody on the test is going monochromatic, one color. And I'm not going to have my bond straightening tool going on here because you don't have one on your test. Oh, you do. It's called a ruler if you want to bring one. But using a ruler takes time. Just saying. Do your best. Here's your 4 points. It begins. You do your parallel lines. Make sure they're not straight up and down. You won't get a good chair if you go straight up and down. They have to be on an angle. From the inside corners, 2 more parallel lines. Don't draw them horizontal either. They have to be on an angle. And they go more than half of the way to the other green line. And then finish. This is a acceptable first chair. The second chair looks like the mirror image, but it's not. It's after sigma rotation, it just happens to look like the mirror image. More than halfway, more than halfway. Finish it off. Then zoom in on carbons 1 and 4 and 2. Why not 2? Because it's got groups on it. And put all the bonds on. Always put axials on first because they follow the carbon angles. Carbon angle up on carbon 1. Axial, straight up. Carbon angle on 2, down. Axial, straight down. Carbon angle on 4, also down. Axial, straight down. We're doing axials first. Other chair, bottom right should be carbon 1. Same thing, put axials on first. Straight down, angle down, straight down axial. Angle up, straight up axial. Angle up, straight up axial. Equatorials last. If the axial is straight up, then the equatorial slightly down. And I want to remind you, it needs to be parallel to this and this. Same story here. Slightly up because the axial was straight down. And parallel to this and this. Carbon 4, axial straight down, equatorial, therefore slightly up, parallel to 2, 3, and 5, 6. Other chair, same story. I'm going to move this guy here. Slightly up, parallel to 2, 3. This is the one where I see badly drawn equatorials often. The students will do this by mistake, and you are going to tell me what's wrong with that. That is not a good slightly down for this equatorial. Why not? It's not parallel to this and this. Don't put it slightly down to the left, because these bonds point slightly down to the right. There. Parallel to that and that. Same story here. Equatorial, slightly down, parallel to 5, 6, and parallel to 2, 3. Gonna move one of my chairs a little. If it lets me. It did. There. We're getting there. Carbon 1, the black bond is up. Which of these two bonds is up? The wedge, because wedge means up. You draw the 1, 2, 3, 4, 5, 6, the hexyl group on the black bond. And we'll put groups in blue. 1, 2, 3, 4, 5, 6. Don't forget the end of a stick is a methyl unless you tell me it's not. So and notice it, the H is down. How do you know it should be down? Because you did this pre-work and you figured out it needs to be down. Carbon 2, it doesn't matter. You put a bromine on one of the bonds and another bromine on the other, right? Carbon 4, which of these two is up? Isobutyl or hydrogen? Isobutyl. Draw the isobutyl. 1, 2, 3 with a V. And don't forget, down is an H. Unless you put, if you don't put an H there, you have a methyl. So finally, we're racking up some good points. And then you need to remember what happens when you go from one chair to the other. All the ups stay up. All the downs stay down. All of the axials become equatorials. Your hexyl group goes here. And it's up. Up stays up. 1, 2, 3, 4, 5, 6. H down. Down stayed down. The H was down here. It's down here. Bromines, you don't care because each position has a bromine. H is down on 4, and isobutyl is up. There it is. We're rolling. And C and D are easy. Which group's bulkier? Translation. Which group has a branch closer to the ring? Well, hexyl doesn't have a branch. Isobutyl has a branch, 2 carbons from the ring. Isobutyl is the bulkier one. Bromines are very bulky, but hey, you've got a bromine axial and equatorial in both chairs, right? Bromine's not part of your discussion. But you are circling this chair that puts the bulkier group on what kind of bond? Isobutyl is on what kind of bond? Because I didn't do my labels. EQ is acceptable short form. And AX here, we're supposed to label the R groups, the carbon groups. It says in the question right here. Label those as axial or equatorial. And here we have Ax and EQ. As promised, in one chair, if the group is equatorial, the other chair, the group is axial. And similarly, if in one chair, the group's axial, in the other chair, it needs to be equatorial. Summary, up stays up, down stays down, axials become equatorials, equatorials become axials. There's your summary. And then D is easy. Tell me the words you know that I like. You gotta tell me you picked that because the bulkier isobutyl is avoiding the negative interaction over here called, yeah, I'm hearing it out there. It's very soft. So for the video, somebody was saying 1,3 diaxial repulsion. Need those magic words. Okay. And I'm going to make it so we can see the whole thing. And if there are no questions, I'm going to stop the video, and that's going to be a segment. Yeah. And we hope it worked. I did a test this morning. It worked this morning. Just hope it works. So we're stopping. And Andy.